For the third time in 2025, a robotic lander is aiming for a touchdown on the surface of the moon. In February, Intuitive Machines Nova C lander took the fastest route, landing in less than a week, but ending up on its side. Then, in early March, Firefly Aerospace's Blue Ghost lunar lander touched down after traveling in space for nearly 2 months. And next up, on June 5th, Japan-based company ispace will attempt to land its robotic lander on the moon. The mission is dubbed the SMBC by HAKUTO-R Venture Moon Mission 2. It's a partnership primarily between Japanese companies iSpace Incorporated and Sumitomo Mitsui Banking Corporation. Its lander, called Resilience, is aiming for a part of the moon in the northern hemisphere called Mare Frigoris. That's Latin for Sea of Cold. It's located at approximately 60.5 degrees north, 4.6 degrees west on the Earth-facing side of the moon. The volcanic region was imaged ahead of the landing attempt by NASA's Lunar Reconnaissance Orbiter. Mission 2 is the second bite at the apple for iSpace after its first HAKUTO-R mission had a hard landing back in 2023 and wasn't able to return any science data. Before the launch of Mission 2, we sat down with Ron Guerin, the CEO of iSpace's U.S. division, who explained why Mission 1 didn't go to plan.
Yeah, well, the good news is the hardware worked exactly as we expected, so there was no real hardware issues to speak of. What had happened on our first mission is, as we were getting ready to land on the lunar surface, and everybody's in mission control and everybody's excited, the plan was to land in the bottom of a deep crater. And as we passed the rim of the crater, the radar altimeter all of a sudden saw a huge jump in the altitude. So the cliff, it was a very steep cliff, about 5 kilometers deep, so we're talking really deep. But as we crossed that rim, and the altimeter, the radar altimeter showed this big jump, the software kicked it out, right? It said, okay, that's impossible. You can't have a 5,000, meter jump like that. And so that was the truth data. And so what we end up doing is ignoring that altitude and then making a pinpoint soft landing 5,000 feet above the bottom of the crater, or 5,000 meters above the bottom of the crater, roughly, and then just hovering there until the spacecraft ran out of fuel, right? And so we've obviously fixed all that software. We're not landing in the bottom of a deep crater this time, and so our confidence level is a lot higher on this one.
iSpace's journey of roughly 4.5 months is coming to a conclusion soon.
6, 5.
It began with the launch of the Resilience lander back on January 15th.
Ignition. And liftoff. Go Firefly, go iSpace, go back.
Alongside Firefly Aerospace's Blue Ghost lander. After Blue Ghost was deployed,
upper MPC separation confirmed.
A protective canister was jettisoned about an hour and 12 minutes after liftoff. Roughly 20 minutes after that,
iSpace Resilience separation confirmed.
Resilience was on its way. Following its long coast, as illustrated on this map that represents the mission trajectory, the spacecraft entered into lunar orbit at 2041 UTC on May 6th with the completion of its roughly 9-minute translunar injection burn. Guerin said iSpace was very intentional when choosing a coast phase lasting more than a third of the year.
What the low energy transfer allows is us to trade fuel for payload capacity, margin. It just leads to more capability for us to bring to the lunar surface.
The big finale is coming up on June 5th at 1917 UTC, when Resilience is expected to land safely on the moon.
There's a lot of pucker points, to use your phrase, but probably the biggest pucker point is that final descent to the lunar surface, because that's pretty tricky, and there's a lot of hazards on the moon and a lot of things to watch out for.
iSpace's Resilience lander has a square base of roughly 2.5 by 2.5 meters, or 8.2 by 8.2 feet, and is about 2.3 meters, or 7.5 feet tall. It has a dry mass of 340 kilograms, or roughly 750 pounds. It'll use its one main thruster, along with 6 assisting thrusters, to make the touchdown. The main thruster was installed back in late 2023. The Resilience lander carries with it a suite of 5 primary customer payloads. There are 3 science-driven payloads, a deep space radiation probe from the Department of Space Science and Engineering at the National Central University in Taiwan, a food production experiment called Luna from the Uglena company, and an electrolysis demonstration from Takasago Thermal Engineering. And then there are more artistic payloads. One is a commemorative alloy plate from the Bandai Namco Research Institute, which is the R&D arm of the Japanese entertainment company. It's inscribed with a message modeled after a piece of lore from its anime series called Mobile Suit Gundam UC. The other comes from Swedish artist Michael Jenberg, who is sending a model of a traditional Swedish cottage known as the Moonhouse. It's an art installation he's dreamt of putting on the moon for a quarter century.
It's really difficult to know. Maybe it will feel really empty that it is the project is ending, or maybe it will. I think that it might depend on the reactions of others. And so far, people do get provoked by it, of course, as well. I mean, that's natural, but that's also kind of the purpose of art. Yeah, I mean, you want people to get emotionally involved, and somebody gets annoyed and think that that's rubbish, and some people get really inspired by it, and that is the purpose. And if that can continue at least for a while, I would be super happy about that.
It's really important to reach not just the brain, but the heart as well in folks. And I think, as we communicate to folks through different channels, not just technical channels, but, emotional channels as well, hopefully we'll get more people behind the effort and behind what we're trying to do and what the other companies that are in the same industry are trying to do to basically extend a human presence to the moon for this time to stay.
iSpace itself also has a payload on the lander in the form of this shoebox-sized micro rover called Tenacious. It was manufactured by ispace-Europe in Luxembourg.
We are flying the European rover from ispace-Europe on this mission, and so it's really exciting. First time it's flown, and we do have experiments on the rover.
Tenacious measures 26 centimeters tall, 31.5 centimeters wide, and 54 centimeters long. Converted to the Imperial system here in the U.S., that's about 10.2 inches tall, 12.4 inches wide, and 21.3 inches long. Its frame is made up of a carbon-reinforced plastic, and it has wheels designed to handle the challenging terrain on the moon. It also has a forward-mounted HD camera to capture the lunar landscape, as well as the Swedish house, which will hitch a ride on board.
As soon as they have done all their commissioning, all their tests, it should be the Moonhouse time. And then what it starts with, it will start scouting for a good place. As you saw in the previous picture, we want to have a good geometry. We want to make sure we have the perfect lighting from the sun. If we can have the Earth in the background, that would be fantastic. That may be difficult. And of course, it would be nice to have a good scene on the moon, have the right size rocks, or maybe a hill as it was on the picture there. And once we've selected this, we'll go a long tour around to place, as you see, the house is mounted on the back side. So in order to get a picture that is in the light side, we need to have faced the sun as it is here, and then go back around so we don't get any tracks in front of the house. After we deploy the house, of course, and then we'll go back to a couple of or three camera angles and take the pictures.
It's a really exciting artistic endeavor as well.
So technically the first housing development on the moon.
That's right.
That's designed to stay there.
That's right, for very, very small people.
Exactly.
Following the landing sequence, Garin says iSpace will conduct some quick checkouts to make full use of all the time they have during the lunar daytime.
There's safing that has to occur on the spacecraft, right, to be good stewards of the lunar environment, and then obviously payload checkouts. And so it's going to happen very rapidly. The clock is ticking because we're only going to be operating during daytime. So if we get there perfectly, then that's around 14 days of operations. We have a lot to do in 14 days, and so we want to get going as fast as we can.
Like the commercial landers before it, Resilience isn't designed to survive the lunar night. That's a problem iSpace is working on across its Japan and United States divisions.
Really, in order to have sustainable operations on the moon, to start a cislunar economy, you have to be able to survive the night. So there's, millions and millions and millions of dollars that are put into these missions, and if they only operate for 2 weeks, that's not a very good return on investment, right? So we want to be able to do surface operations for months or years at a time, and so in order to do that, you have to be able to survive the night, and that all centers on being able to heat your equipment to make sure that when you get into the really, really low temperatures of lunar night, that you're not going to destroy all your electronics and all your equipment.
Most recently, in late April, iSpace announced a Memorandum of Understanding with Entex Limited, an Australian nuclear engineering company, to develop a technology demonstration of Entex's radioisotope heating unit for a future iSpace mission. Similarly, earlier that month, the United States division of iSpace announced a separate MOU with Xenopower Systems, Inc. to conduct a demonstration mission as soon as 2027 with Xenopower's radioisotope power systems.
Xenopower has done a lot of great work on the regulatory side to enable them to actually fly these nuclear fuel sources, both from LEO to cislunar space. And so they're working very diligently on enabling the regulatory front. And so our collaboration in the near term will be understanding how do we actually deploy these systems and enable a very mass efficient power enabler for the surface.
This second mission from iSpace will also help plant the seeds for a future large-scale off-world economy. Once on the moon, iSpace will execute a pair of contracts between itself and NASA.
We're going to capture a regolith in the footpads of the lander, and we have a scoop that was actually designed by a mining company, so inter-industry collaboration that will actually scoop up a portion of regolith, and then we will do a transfer, contractual transfer to NASA for ownership of that sample.
What do you think that, this first overture in transferring property on another celestial body will teach, iSpace, teach NASA about how the true economy of the moon, not just getting things to the moon, but within the cislunar space, what that means and how that works?
Yeah, I think this is really important. It's a legal demonstration, right? I mean, it's a technical demonstration, but it's also a legal demonstration, which hopefully sets precedent that will lead to the development of a cislunar economy, lead to the development of a commercial market on the lunar surface as companies realize, there's revenue to be generated here, and hopefully that leads to a permanent, significant human presence on the moon.
iSpace is just one company hoping to see a cislunar economy realized. But even before the U.S. administration proposed heavily slashing NASA's budget, Garin had his concerns when it came to how strongly committed the U.S. would be towards a permanent human presence on the moon. Garin knows a thing or two about America's space program. He's a former NASA astronaut who started his training back in August of 2000. He flew to the space station twice, once as Mission Specialist 2 on STS-124 in 2008, and again in April 2011 as a member of Expedition 27/28. In all, he's racked up more than 178 days in space and amassed just over 27 hours of spacewalking time across 4 EVAs.
The biggest problem that, in particular, the U.S. space program has is a tendency to shift strategy administration to administration. With the exception of the last couple of administrations, which were outliers, we've stayed the course to the moon, right? And there is a strong political imperative to get back to the moon. Hopefully, that imperative extends to and stay. The and stay part is the tricky part. I agree with the folks who think our next step is a return to the moon, but a sustainable exploration of the moon. I think if we do that and we do it right, that will open up exploration for the rest of the solar system, including Mars. It also is a way for us to test out everything that's at our closest neighbor, 3 days away versus months and months away, for instance. The list goes on and on why it just makes so much more sense to really set up the infrastructure on the moon before we make any really huge, significant investments, especially for human exploration anywhere else. It doesn't really answer your question because I don't know if Congress, Senate, the administration is going to share on that and where the political winds are going to blow.
While the world waits for an answer to that question, Garin says iSpace will have a busy 2025 even after Mission 2 is done and dusted, however that ends up turning out. The first lander produced by ispace-U.S. will continue development in partnership with the Charles Stark Draper Laboratory as part of NASA's Commercial Lunar Payload Services Program, also referred to as CLPS. But in early May, iSpace announced a delay in the launch of the Apex-1 lander for that mission from 2026 to 2027. That's because they're moving away from using Agile Space's A2200 biprop engine to instead using a new engine called Void Runner, which is being jointly developed by ispace-U.S. and Agile Space. The change will require adjustments to the lander's design from what they've shared previously, hence the one-year delay. Garin calls the Apex 1.0 lander a, quote, quantum leap from the Resilience lander.
So just to illustrate that, the payload capacity of the Resilience lander is about 30 kilograms to the lunar surface. The payload capacity of the Apex 1.0 is about 300 kilograms to the lunar surface. We also have the capability to deploy relay satellites along the way. And so our first mission, which is in partnership with Draper Laboratories, is a CLPS mission. We're landing in the Schrodinger Basin on the far side of the moon on the South Pole on our first mission. And we will deploy two polar orbiting, lunar polar orbiting relay satellites on the way in. And then, like I said, a capability to bring 300 kilograms to the lunar surface with rovers and a lot of other really exciting things. So a very, very challenging mission for the first mission of Apex 1.0, first mission of ispace-U.S. That will be followed shortly thereafter by another mission from Japan with the new lander. So we're developing the follow-on to the Resilience lander, which has more capability comparable to the Apex 1.0 lander. Our rover development will continue throughout that period. And so we want a steady cadence of lunar missions so that everything isn't happening in parallel.
But with Mission 2 about to reach its own apex, Garin says he can picture what that moment of reaching a successful touchdown will be like.
We have an all-hands room in ispace-U.S. and in big letters across the wall is the other words, touchdown confirmed, exclamation point. And so that is the vision that we are projecting, the positive, visualizing a positive future, but I think it's going to be an incredibly emotional experience. I think everybody is going to feel a sense of pride and relief and that they accomplished something really remarkable, which we will have accomplished something really remarkable if that telemetry comes across the screens. So.
Reporting for Spaceflight Now, I'm Will Robinson Smith.